this Astropictionary concept video, we want to go over trends in stellar evolution. We're looking at the stellar evolution trends off the main sequence, starting on the main sequence and moving off the main sequence of an HR diagram. So here we're looking at an HR diagram. We have different stars plotted on the diagram based on their luminosity and their temperature. Luminosity is on the left, on the vertical axis, with increasing going upward. Temperature is on the horizontal axis, with increasing going to the left. Notice we have different stars plotted on the diagram, and they're drawn in different sizes based on their size, and they're drawn in different colors based on their surface temperatures. We have many stars along the diagonal from upper left to bottom right, and this is called the main sequence. The main sequence is a section of the HR diagram where stars are considered adult stars. They're fusing hydrogen into helium in the cores of their stars. The masses of these stars are known, and instead of looking at the individual mass numbers, we have divided the main sequence up into segments. The very lowest mass stars, very, very low mass stars, or VVLMs, are at the bottom right corner. At the opposite end in the upper left corner, we're going to have our VVHMs, which are very, very high mass stars, which just happen to fall off of this diagram. The diagram just can't have all the stars on there. So we will just put an arrow to the upper left indicating that the diagram does increase in the upper left direction, and we're missing a category, the very, very high mass stars. Once again, at the very bottom right corner is our very, very low mass stars. Moving up the diagonal towards the upper left, we've got very low mass stars, then low mass stars, then intermediate mass stars, high mass stars, followed by very high mass stars, and then very, very high mass stars. Notice how they echo each other around the intermediate mass. At the extremes, we have very, very high mass at the upper left and very, very low mass at the bottom right. Then we have very high mass in the left and then very low mass in the right. Then we have high mass in the left and low mass in the right with intermediate mass in the middle. So they're almost mirror images of each other, with high being on the upper left side and low being on the bottom right side. Now we want to look at trends in stellar evolution off the main sequence. The first one we can look at is the fusion chains. There's 3 fusion chains. You've got PP fusion chain, you've got the triple alpha process, and you've got the CNO process. In general, we can just draw a line right between the intermediate mass and low mass. And generally, everything to the bottom right, from low mass to very low mass to very, very low mass, they're going to use the PP fusion chain. The low mass stars will also use the triple alpha process. Anything along the main sequence to the upper left, that's the intermediate mass, the high mass, the very high mass, and the very, very high mass, they're going to go ahead and use the CNO process. So we see some trends. We divide the diagram in half. The lower half uses the PP fusion chain. The upper half uses the CNO. And it just so happens the low mass stars also use the triple alpha process, fusing hydrogen into helium and building more mass inside the core of the stars up to the mass on the periodic table of iron. So now we looked at these trends in fusion. Let's go ahead and take a look at a different category of trend. The next category we're going to look at is lifetime, or age on the main sequence. So we want to take a look at the age. So we're looking at age now. And specifically, this is age on the main sequence. Down at the bottom end, you have ages that are going to be old or long. Whereas in the upper left, you're going to have very short. So age goes along the main sequence from the bottom right corner up to the upper left corner. So we can draw a line along the main sequence and just put age here. Now we're specifically talking about main sequence age. How long do these stars sit on the main sequence before they start evolving off? The ones that are at the bottom, the very low mass stars, are long ages. In fact, these red dwarfs have not moved off the main sequence. They're all still sitting on the main sequence. None have evolved off yet. Whereas on the upper left, your very, very high mass and your very high mass have very short lifetimes. Many of them have already evolved off the main sequence, and they turn into these supergiants and the hypergiants. The very, very high mass stars turn into the hypergiants, whereas the very low mass stars evolve into the supergiants. So I'll go ahead and put at the top hypergiants because they fall off the diagram. Remember, the diagram continues both up and to the left, so we have to expand it out. And this particular version of the HR diagram looks at the lower section more than the upper section. So now we looked at age on the main sequence, and the trend is going to be with the long ages down at the very low mass and the short ages on the main sequence at the upper left at the very high mass. We did not include the category of the very, very low mass objects because these are generally the brown dwarfs. And these brown dwarfs don't live very long as stars, and they die off rather quickly, and they die off like planets. So we want to not include that in our trend. So now that we've looked at the age trend on the main sequence, let's go ahead and look at another category. And that category of trend is going to be evolution. Let's look at evolution. Now we know that these low mass stars, they evolve into subgiants first, which are located right about here. And then they evolve into giant stars before they turn on along the horizontal branch, and then they go up the asymptotic giant branch. They eventually end up over here in the planetary nebula stage, and then they end up dying down here along the white dwarfs. They're intermediate mass stars. They also evolve into white dwarfs, and we think that the very low mass stars evolve into the white dwarfs as well. So there's your trends for the lower half of the diagram. The very low mass, the low mass, and the intermediate mass are expected to evolve into these white dwarfs. What about the upper end? Well, let's erase our evolutionary tracks here. They get kind of messy. And let's take a look at the other end. We're looking here at the high mass stars and the very high mass stars. The high mass stars turn into supergiants, as well as the very high mass stars, and they might even make this little turn if they have enough age on them evolving off before they eventually die into the neutron stars for the high mass objects, and the very high mass and the very, very high mass evolve into the black hole stars. So we can see a common trend here. The very, very high mass stars and the very high mass stars evolve into the black holes. It's just that the very high mass stars evolve into supergiants first before black holes, and the very, very high mass stars evolve into hypergiants before the black holes. But they end up as the black holes. So we see some commonality. The only unique one is the high mass stars, which evolve into neutron stars. Now, one thing that is different for both high mass and low mass is that the giant stars of the low mass do not evolve into supergiants. These low mass stars evolve into subgiants and giants. So these low mass stars evolve into subgiants and giants, whereas the high mass stars evolve into supergiants, and the very, very high mass stars evolve into the hypergiants. So you'll never have a case where the subgiants and giants turn into supergiants or hypergiants, and the other way around. You won't have hypergiants and supergiants evolving into giants or subgiants.